Alrighty, section 3.2, slope of a line. Slope of a line. Very important. Remember, my notes are just a little bit different than yours, only in the sense that they're spaced out differently. All of the same stuff should be there. Alrighty, objective number 1. Using rise over run to find slope. So let's define slope, that word, first off. What does that mean? What does slope mean? What is a slope? You guys talk about it for a sec. Alrighty, I hope somebody said the slope, the steepness of a line. Now, in our case today, we'll be talking specifically about linear lines, but slope can be found in a lot of lines. It's just the steepness. How fast are you rising and running? Like how fast do you go up and down? You can have positive slopes. Positive slopes go this way, right, going up. You can have negative slopes. You could have, we'll talk about zero slopes, and we'll talk about undefined slopes in just a sec. But you can have a lot of different kinds of slopes. So the positive ones go up, the negative ones go down. To find them, you use something called rise over run, right? So how far did you rise, how far did you run? And we've actually kind of seen this concept a little bit in the last section when we were working with distance. If you recall, we had 2 points, right? Look something like this. And we wanted to find the distance in between them. We would say, okay, to do that, I can look at how far down, or how far up and down it went, and I can look at how far over it went, and I can use the Pythagorean theorem to find out how far that distance is. Luckily, we can use those same two numbers to find the steepness. So the distance and the steepness are very, very, very closely related. Instead of calling it d, we're going to call it m, right? Because it's not the distance. We're not finding the distance. We're finding how steep it is. We're going to call this slope the m every single time. But we're going to use that same up and down, that rise, and that same run, that horizontal length. So, and we'll put them over each other, rise over run. So in other words, rise over run is the changes in the y's over the changes in the x's, or y2 minus y1 over x2 minus x1. Now remember here that the y2 and the y1, so y2, it's not something super fancy, it just means the second y, right? So if you have y1, that's the first y. If you have x2, that's the second x, and x1, that's the first x. And that's just the formula to plug into. Same defined as last time with the points and the distance and the points for the midpoint formula. So hopefully you've seen these ones before. I know if you took my class a few years ago, you definitely have seen these before. But we're going to use these to find the slope of this line down here. So let's take a look at this line here. Alrighty. So over here, we can see they picked out 2 points for us. Let's just use those so we can stay on the same page. 1, 5 and 2, 8. Let's go find those here. So 1, 5, remember that's x, y. So you want to make sure you go out 1 and up 5. Let's see, that's right about here. So that's going to be our 1, 5. And then our other one, 2, 8. So we're looking at this point and this point, 2, 8. So out 2 and up to 8 would be right about there. Alright, so we got these 2 points. You can use any 2 points, though the steepness of the line for a linear line will be constant no matter where you are on the line. So you can use any 2 points you want when finding linears. That changes a little while down the road, but right now you can use any 2 points you want. Alrighty, so let's do the same thing we did for distance, right? Let's look at that rise and that run. Let's see, how far did this one go up? Let's see, from 5 to 8, that's 3 units. So it went 3 units up, right? And then how far did it go out? It went out from 1 to 2, that's 1 unit. So our slope would be rise of 3 over run of 1, or a slope of 3. It's a slope of 3. Fabulous. That's what that way we call geometrically, right? On the graph, geometric. So if we can do it geometrically, definitely always plot 2 points and count. Little harder if you've got fractions and decimals and stuff, but luckily there's also another way we can do this, an algebraic version. The algebraic is using the formula, right? So if we look over here, they've actually done it for us. That formula, remember the second x minus, or sorry, the second y minus the first y. Well, we already talked about that, the changes in the y's, right? From the 8 to the 5. Or 8 minus 5, that was 3, right? So same concept, just doing it in a, a fraction or a formula instead of on the graph. 8 minus 5 is 3. Same thing with the x's, right? We saw that the x's move over 1 from 1 to 2, or 2 minus 1 equals 1. We end up getting the same slope of 3. So if you want to do it geometrically, that's totally fine. If you're a visual person, kind of like myself, you need to see stuff on a page, then definitely, do a graph every single time, but it will be much easier if you can just do it algebraically and you can remember that formula, the changes in the y's over the changes in the x's. All right, let's do it again with this example down here. So we're going to scroll down just a little bit. So finding the slope of the line given these 2 points. We're first going to start it geometrically, then we'll do it algebraically. So geometrically, we've got 2, -1. Let's go plot that on the graph. Out 2 and down 1 would be over here, right? So that's our first point. That was this point here. And then I'll use a different color for my other point. We'll use blue. Of -5, 3. Now remember, that doesn't mean down 5, out 3, right? We do the x first. So that means back 5 and up 3. Back 1, 2, 3, 4. Oopsie, that was not enough. So back 1, 2, 3, 4, 5, up 1, 2, 3. Right there. Okay, good. All right, so now we've got these 2 points. Let's figure out what the steepness between them is. So let's draw a line in between them. At least a decent line, right? And then we'll count how far up they went and how far over they went. So how far up would be our rise. All right, it's looking like, let's see, I went 3, 4, right? Now remember, I'm measuring how far up between the 2 points. I'm not measuring from the axis. That's something we see a lot. Don't measure from the axis, measure from the points, like how far the points are apart. And that looks like 4. And now let's measure how far across. So it looks like across, use orange. Across would be, let's see, 1, 2, 3, 4, 5, 6, 7. 7 across. Cool. Did I plot that right? Nope, yep, I plotted that right. So 4 and 7, fabulous. Questions so far? Awesome. All right, so then we do the rise over the run, right? So 4 over 7. Tiny thing though. Remember, up here, we went out 1 and up 3, right? A nice positive slope. Here we did not go up 4. We went from here down 4. So this is actually going to be a -4, down 4. And now, so this would be a -4 over a run of 7, or a slope of -4/7, right? It doesn't really reduce, so that would be our fraction. Alrighty, let's see if we get the same thing algebraically. So here we've got our 2 points, right? I'll try to stick to colors. Our slope formula, if we recall from up here, is the changes in y's, y2 minus y1 over x2 minus x1. And so what would be our y2? Well, that means our second y, right? Our second y. So that would be 3 minus, what's our first y? -1 over our first x, or I'm sorry, our second x, -5, minus our first x, which is 2. Alrighty, so I just plugged it in as I saw. This blue one right here was that 3 there, right? And then this -5 was on the bottom. It's the blues minus the purples. Okay, now we'll simplify a little bit. 3 minus a -1. Remember, minus a negative makes it a positive. So we've got 4 over -5, take away 2 more, -7. And since it's a fraction, the negative can go on either the bottom or the top. -4/7 is our slope. And that's exactly what we got when we did it geometrically. So either way, we got -4/7 as the slope. Awesome. Alrighty, let's take a look at this, finding the slope again, right? We'll find the slope, but this time we're going to do it from an equation. So we've got this equation here, 4x minus y equals -8. Recall, this is what it looks like in standard form, the standard form of an equation. where you've got a number times x minus another number times y equals a constant. So ax plus by equals c. Now, we still need to find the slope, we still need 2 points. What can we use as those 2 points? Well, we could plug in any 2 points we wanted and find the slope. That's absolutely true. But instead of doing that, because you never know, you're going to end up with fractions, and then you have fractions and fractions, it'll be horrible, we should look at 2 very specific points, ones we already know how to find. Anyone know which ones I could think of? Hint, hint, they're in my little box. That's right, the x and y intercepts. Let's find those. We'll use the x and y intercepts as our 2 points. We already know how to find those from the last section. It'll be very easy to just repeat the process here. So let's recall my x-intercept. Well, that's where I cross the x-axis, right? And since I'm at the x-axis, I've gone up and down nothing, right? So that is where my y equals 0, right? I've gone up and down nothing. So that's where my x-axis would be. That's my x-intercept. So in order to find my x-intercept, I plug in y equals 0. Well, here's my equation. 4x minus y equals negative 8. And I know y equals 0, so I'll plug it in for y. So 4x minus 0 now equals negative 8. Well, anything minus 0 is not going to change anything, so that kind of just goes away. I get 4x is equal to negative 8. Notice using the 0 is very, very simple, right? So that's why we want to use our x and y intercepts. Then divide by 4, you get x equals negative 2. And so our x-intercept would be negative 2, comma 0. Now, this last part here, if solving for a single variable is difficult for you and you're not quite as fast, then you definitely need to practice, okay? So use some problems from the book, or come see anybody after school, or email me, that's fine too. But this should be fluent by now, being able to plug in a number and then solve for the other one. If that's still sort of a weak area for you, that's okay, right? That's okay, but you do need to practice, okay? Because it's only going to get more complicated from here, and if that's still an issue with you, you need to fix it, okay? Now, I'm not saying you're like behind in the class or anything, don't worry. I'm just letting you know that you need to make sure you get stuff like that. Get your questions answered is what I'm trying to say. Make sure you always get your questions answered. All right, let's do the same process for the y-intercept now. So the y-intercept is the same yet opposite, right? Instead of looking at the x-axis and where it crosses the x-axis, we're going to look at where the line crosses the y-axis. When it crosses the y-axis, we've gone out nothing, right? We've gone over nothing, so our x would be 0. So for x-intercept, the y is 0. For y-intercept, the x is 0. And so we'll plug in x equals 0. So x times 0 minus, not minus 8, minus y. Oh no, pardon me. Okay, hold on, sorry, technical difficulties. Just erase that and start over. 4 times 0 minus y equals negative 8. Anything times 0 is just going to go away. So it would be 0 minus y, and 0 minus y doesn't change anything. So minus y equals negative 8. And then divide by negative 1, you get y equals 8. So for x is equal to 0, let's do green. Let's do green that's not ugly. Y is 8. 8. Alright, so we have our 2 points, negative 2 comma 0 and 0 comma 8. Now, why were we doing that? Do you remember why we found the x and y intercepts? Because it definitely wasn't in the question. The question is find the slope of the line, right? So if we need the slope of the line, we found the x and y intercepts so that we could use the slope formula. So the last part of this problem is to use the slope formula, y2 minus y1 over x2 minus x1, right? That's what we needed to find. So in order to have an x2, a second y, or a second x, we needed to have 2 points. And that's why we found our x and y intercepts. So let's go use those now. We'll do the x-intercept as our first point, the y-intercept as our second point, though that is entirely up to you. It should work out either way. So our second y would be 8, and our first y would be 0. Also, again, using the 0, right, the y-intercept, and the x-intercept gives us zeros, and that makes our computations pretty straightforward, right? 8 minus 0, that's really nice. Over our x's would be 0, second x is 0, minus our first x of negative 2. That one I have to be a little more careful about because it's minus a negative, but it's still pretty straightforward. All right, 8 minus 0 over 0 minus negative 2 reduces down to 8 minus 0 is 8. Let's see, 0 minus negative 2, what happens there? That's right, we get a positive 2. So our slope, 8 divided by 2, is 4. Alrighty, so 3 parts of this problem. Find the x-intercept, find the y-intercept, find the slope. Pretty straightforward though, right? Pretty straightforward. Using stuff we've done over and over and over again. Or at least we've seen the last section. Alrighty, let's talk about 2 different types of slopes now though. Like I said before, way at the beginning, we have, oops, where my box went, sorry. We have a bunch of different types of slope. We have positive slope, negative slope, and then we have 2 different ones called zero slope and undefined slope. One of which is going to be this equation, one of which is going to be that equation. If you recall from the last section, these are those special types of lines, those horizontal and the vertical. So if you remember, horizontal, side to side, vertical, up and down, right? So horizontal looked like this, and vertical looked like this. Now, which one was which? Which one of these had an equation y equals something, y equals a number, and which one of these had x equal a number? Remember? We'll play a little matching game. That's right, that's right. If you have only y's, right, your up and downs, that means your x's are 0. It doesn't matter what your x's are, so that would be horizontal. So these 2 would be the same. So horizontal is x equals 2, right? And then if you have a vertical line, that's going to be your y's are all equal to 0. It doesn't matter how far up or down you go, right? So you can go up or down as much as you want. That would be your x's. It sounds a little opposite, right? Don't think of your axes when you think of that. Think of the opposite of your axes. Your x is 0 on all of your y-axis, right? So it doesn't matter. Therefore, it's a vertical line, right? So don't think of your axes. That's where people often switch these up. So think of it the other way around. Whatever part you're missing, that's the line you want to draw, if that makes sense. Or you can just memorize it, right? Horizontal y, vertical x. Okay, so then we look at this equation in 2.2a, right? We got 2.2a, y equals 2. What kind of line is that? That would be a horizontal line. Good, horizontal. So now let's think of that slope, right? So we'll think of the slope. We got this horizontal line, and we've got 2 points on there. We can pick any 2 points we want, right? Luckily, it's going to be the same for every single horizontal line, no matter what. But if I've got 2 points on this horizontal line, let's think of that rise over run. It's still a slope, so it's still rise over run. But let's take a look at this. Is there going to be a rise? Is there going to be a rise on a horizontal line? Are they going to go up and down anything? No, they're not. So the rise is going to be 0, but they are going to run something, right? They're going to run like 2 or 5 or 6 or something like that, right? So it'll be something like 0 over 6, or even better, 0 over some number, no matter what we do. For any horizontal line, that excuse me, that rise is not going to change. That rise is going to be 0. We'll come back to what that means in just a sec, but let's take a look at the other one. Recall that this means, this is the same thing as x equals -1, right? So it's a vertical line. Looks kind of like this, right? And we could pick any 2 points we want on there. Pick any 2 points on the vertical line. Let's again look at rise over run. Is it going to have rise? Is this line right here going to have rise up and down? Definitely, right? It's going to go from -5 to +6 or something like that. So it's definitely going to have some rise, some number. But is it going to run? Is it going to run from side to side? No, it's not, right? Because that x is equal, that y part is not part of the equation. It's not going to run. So it's 0. All right, so this one's always going to be something over 0. Now, which one of these is legal? Which one of these am I allowed to actually compute? If I had 4 over 0 or 0 over 4, which one of these 2 slopes would actually make sense? That's right, the first one, right? You can divide by 0. This one is okay. This one would just give you a slope of 0. Anything 0 divided by anything is okay. However, this one, you can't divide by 0. So this one is what we call undefined. Or you'll see it sometimes in your homework as D and E does not exist. Okay? Now, that doesn't mean you can pick every single slope and call it D and E. It's only the ones for vertical lines, all right? Vertical lines have a do not exist slope. Horizontal lines have a 0 slope. It really depends on whether you're running forever or you're rising forever, right? So if you have a run, you're good. If you have a rise, it's not good. Cool. Hopefully you can catch the difference between those. So over here down at the bottom, you said a horizontal line will have a 0 slope, while a vertical line will have a undefined, I've run out of room, undefined slope. Undefined slope. So 0 for horizontal, undefined for vertical, but you can write 0 and D and E for does not exist. Alright, cool. Alrighty, if you have any questions about horizontal and vertical, because those can be very confusing, please pause the video now and discuss them. Other than that, we will continue on. Alrighty, finding the slope another way. So you've probably seen this other form before. Before we were talking about equations that looked like this, right? 4x minus y equals negative 8. We called those standard form, right? Where you have ax plus by equals c. Standard form is always great. It's a great way to see everything on one side. It's very organized and clean. There's another form, though, that actually shows you your slope. You can just pull it right out of the equation. So it's very, very easy slope to work, or a very easy form to work with. It's actually called the slope-intercept form. That name is not trying to trick you or give you a whole bunch of stuff to memorize. It's trying to show you what is in the form. It's the slope and then the intercept. So you probably remember it as y equals mx plus b, which you will see down here. So y equals mx plus b. I guess we can erase that, save ourselves some room, right? But down here you'll see y equals mx plus b, where m is still the slope. That is always defined universally. M is always the slope in a linear. And b is the y-intercept. We'll come back to b when we need to use it to find equations a lot, but today we're just going to talk about that m part, that slope part. And what we're going to be doing is converting standard form to slope-intercept form, which sounds super complicated. It's really not. It's just rearranging formulas, which you guys actually, over the years, I've seen this actually seems to be a pretty easy section for people. So luckily we've got that. So here you can see we've started with standard form, right? And then we move that 4x over, so that, whoops, still in erase mode, that 4x over to the other side, we get negative 4x. And then you divide by that negative and you get everything as positive. And then this ends up being your y equals mx plus b. From there we can see, we can just pull it right out that m is equal to 4, and so our slope is equal to 4, right? So that's what it is. Alrighty. Let's try that out with a different equation. Let's take a look for the slope in this equation. 3x minus 5y equals 8. Now the goal here is to get y by itself. That's how we know we are in slope-intercept form. Okay, so we need y equals mx plus b, and then wherever the x term ends up, we will look there and we will see what is sitting next to it. So let's start with this equation, right? We have 3x plus, oh, I'm so sorry, not plus, minus 5y equals negative 8. Negative? No, positive 8, sorry. I don't know what's up with me. Equals 8. Right, so 3x minus 5y equals 8. We'll start by getting everything that's farthest away from y over to the other side. So always start as far away from the variable as you can, the variable in question. Whether it's with just numbers or with other variables, the rule still applies. Start as far away from the variable as you can. So over here I want to get rid of this 3x. Now I have a positive 3x. I'll cancel it with a negative 3x to both sides. That goes away. That way I'm just left with negative 5y. On this side, those are unlike terms. Unfortunately, 8 and negative 3x, I cannot combine those, so I'll just rewrite them next to each other. Negative 3x plus 8. You are more than welcome to write 8 minus 3x, but remember what we're after is that thing next to x, so we want to kind of set it up in this format where the x comes first. That would be more helpful to us at this point. Nothing wrong about switching it though. Alright, next, y is getting closer to being by itself, but it's not quite there. So we need to divide by that negative 5 to both sides, so that cancels and that cancels. When we do that to the other side, be careful that you divide everything by -5. Everything. If you don't like it in this format, we can rewrite it as divide this by -5 and divide that by -5. But every single term must be divided by -5. You can't just divide the -3. You cannot just divide the 8. Okay? So make sure you do that to everything. And when we finish that, we get, I'm going to go back up here, y is equal to, negative over negative becomes a positive. So 3/5 x plus 8/5. All right, so we've rearranged it into y equals mx plus b. What's our slope here? Now that we have that in slope-intercept form, our slope is what? Our slope is the m. Good, so m is equal to 3/5, and we are done. As soon as we're in that form, we can pull that slope right out of there. There's no more slope formula, no more finding points. That's why we want to put it in this form, right? To save ourselves some time when finding those other slopes. Alrighty, I'm going to let you guys pause the video now. Please pause the video and solve this one. So I want to find the slope of this equation. Go ahead and pause it for about 5-10 minutes. If you have any questions, go ahead and ask the sub, and then we'll come back in just a sec. Okay, hopefully you paused it and you had a chance to try this on your own. Remember, if you don't try in class, it's probably one of the worst things you could ever do to yourself because you're extending your homework time